In today's class, we will be discussing a 5-mark question on differentiation. Okay, differentiation. So the question, the chances of this question are from the last exercise of differentiation, that is second order derivative. Okay, so ಈ question second order derivative dintra pick ಮಾಡ್ತಾರೆ every year, and this question will be asked for 5 marks. Okay, so this 5-mark question we will discuss it today. Okay, so here before going to the question, you need to know some of the key points here. First of all, the first requirement is the formulas. Okay, you need to know the trigonometric formulas. Okay, so you need to know the trigonometric as well as differentiation formulas. Okay, so you need to know this. Okay, if you don't know, make a list of the formulas. Okay, derivatives formulas, whatever the formulas are there. Okay, so you need to know the list of the formulas. So the list is divided into algebraic function. Okay, next after algebraic function, exponential function, third logarithmic function, fourth trigonometric function, and fifth inverse trigonometric function. Okay, so you need to know the derivatives of these all functions. Okay, so the list must be with you. Okay, so now you need to know the formulas. So this is the requirement. Okay, and then second, this question will be asked every year for 5 marks. Okay, so the question is occurring in 5-mark section. It's based on successive differentiation. Okay, so in differentiation there are types. Okay, parametric, implicit differentiation of logarithmic functions, differentiation of parametric functions, and so on. Okay, so in that this is the last concept, that is a successive derivative. Okay, the differentiation. Okay, successive differentiation, or also it is called as a second order derivative. Okay, and then before more going to the examples, you need to know the symbols. Okay, so y, then f of x. Okay, it's one and the same. Next, the first derivative, it can be written as y1. Okay, or we can write it as f dash of x, or dy by dx. Okay, the symbol is same. Okay, and one more symbol is y dash. Okay, so all these symbols indicates the first order derivative. Okay, f o d. Okay, first order derivative. Next, the second order derivative can be represented by y2. Okay, or f double dash of x. Next, d square y by dx square, d square y upon dx square. And second y double dash. Okay, y double dash. So all these symbols are one and the same. Okay, so in some examples they make use of dy by dx, or in some examples they make use of y1, y2, f dash of x, and f double dash of x. Okay, so you need to know the formulas. Next, the question, the exercise number, I think so it is exercise for 5.6. Okay, so these all questions are from the exercise 5.6. Okay, so whatever the questions we are discussing today are from the exercise 5.6. so each and every example of 5.6, the solved example before the exercise, and the miscellaneous examples based on successive differentiation, so these we need to cover. Okay, to cover this 5-mark question. Okay, so we'll start our discussion. So we'll discuss the first question. Okay, students, understood? So you need to know the formulas. Okay, you need to know the formulas of differentiation. So if you know the formulas of differentiation, this question can be attempted. Okay, this question can be attempted. Okay. Yes. Okay. So see, pay attention now. Please off your mic, audio. Pramila. Yes. So see, the first question over here, y is equal to 5 cos x minus 3 sin x, we need to prove that d square y by dx square plus y is equal to 0. Okay, so they have asked us to prove the sum of what second order derivative plus y is equal to 0. Okay, so these questions have the pattern for solving this question is same. Okay, we need to first find the first order derivative and then find out the second order derivative. Okay, so in the solution first we will be considering y is equal to 5 cos x minus what 3 sin x. Okay, so the given function is y is equal to 5 cos x minus 3 sin x. Okay, so first we will be differentiating this. Okay, differentiating with respect to x. So when we differentiate this with respect to x, the derivative of y is dy by dx. Okay, is equal to 5 as it is. Derivative of cos x is minus sin x. Okay, and then minus 3 sin x derivative is cos x. Okay, so on simplifying, we get it in the form of what minus 5 sin x and minus 3 cos x. Okay, minus 3 cos x. Okay, cos x. Okay, next, so this is the first order derivative. Again, we are differentiating this. So differentiating, okay, with respect to x. Again, okay, differentiating with respect to x again. So the derivative of dy by dx, the derivative will be d square y by what dx square. And then on simplifying it further, see minus 5 you keep as it is. Sin x derivative, the derivative of sin x is cos x minus 3 as it is. The derivative of cos x is minus sin x. Okay, is minus sin x. Okay, so on simplifying further, so what we can do here is we can take minus sign common. So in the first term will be 5 cos x and minus sign is taken out common. So it will be 3 sin x. Okay, minus 3 sin x. Okay, so on simplifying it further, see the bracket part is nothing but the equation what they have given. See this equation 1. Okay, and the terms which are present in the bracket are both same. Okay, so we can replace the bracket by y. Okay, we can replace it by y. So this will be the second order derivative d square y by dx square will be equal to minus y, or we need to prove the last step. What we can do is we can shift minus y to the LHS. So this will be d square y by dx square plus y is equal to 0. And this is the required proof for this. Okay. So here only two steps we have done. That is, first we have taken the first order derivative, that is dy by dx. And then again we have differentiated with respect to x. So we have now got the second order derivative. And after getting the second order derivative, we have replaced this bracket minus 5 cos x and 5 cos x minus 3 sin x with y. Okay, so when we replace it, we will get the required proof. Okay, hope the example is clear. All I have understood how to differentiate this. Students, just type yes. So I will proceed with the next question in the chat box. If you have understood it, I will be continuing with the next question. One of you just type yes. Yes, is it clear? Okay. So you can take a screenshot of this. Yes, okay. So we'll be continuing with the second question now. Question number 2. Okay, so question number 2 we will be discussing. Okay, question number 2. Okay. So again, see the given question over here is if y is equal to 3 cos log x plus 4 sin log x, show that x square y2 plus xy1 plus y is equal to 0. Okay. So in this question, they are asking us to show that x square y2 plus x y1 plus y is equal to 0. So see here, y2 it indicates the second order derivative, okay, and y1 it indicates the first order derivative. Y is the given function, okay. So to prove this, first we will differentiate two times, okay. We will differentiate the given function two times, same as the previous example. So see, y is equal to 3 cos of log x, okay, 3 cos of log x plus 4 sine of log x, okay, sine of log x. So here we need to differentiate this, okay. So differentiating again with respect to x, okay, differentiating with respect to x. So when we differentiate with respect to x, the first order derivative, you can make use of dy by dx, or see, as per the symbols given in the question, the first order derivative is nothing but y1, okay. So y derivative will be y1. So I will write it as y1. Okay, so y1 will be equal to 3. See, this is in the form of okay, composite function. So we make use of the chain rule. Okay, chain rule. So first what we will do is we will differentiate cos by consider cos function. So cos function, the derivative will be what? Minus sine of log x, okay, and then the derivative of log x, again we need to differentiate. So the derivative of log x will be 1 by x, okay. Similarly, 4 you keep it as it is, sine log x derivative will be cos log x, okay. Sine x derivative is what? Cos x. So we have got cos log x, and into derivative of log x, it will be again 1 by x, okay. So after differentiating it, once we can see that 1 by x is common, so I will take out 1 by x common. So this will be minus 3 sine of log x, sine of log x, okay, plus 4 cos of log x, okay, 4 cos of log x, okay, and then here we have y1. So what I will do is, in the next step we will shift x to the RHS. So it will be x y1 is equal to minus 3 sine of log x, okay, minus 3 sine of log x plus 4 cos of log x, okay, 4 cos of log x, okay. So again we will be differentiating it once again, okay. So differentiating it once again, okay. Now see here, x into y, it is x into y1. So here for this term we will be applying the product rule, okay. So I'll write it as PR. So product rule. So product rule of derivatives, first function as it is, x as it is, dy by dx, okay, plus y as it is, dx by what? Dy, okay. So first function and second function, okay. So if x and y are two terms, then the first term x will be as it is, a derivative of the second function, and then y as it is, a derivative of the first function, okay. So we are applying the product rule here. So by making use of the product rule, okay, we will simplify it. So see, so on the LHS, we need to apply the product rule. So see, x as it is. Okay, now see, dy by dx. Okay, this is the first order derivative. So when we differentiate, we get d square y by what? Dx square. Okay, dx square. Same way, in case of y1, see now, y1 is the first order derivative. Its derivative will be what? Y2. Suppose, see, if this should be y1 square, okay, then the derivative of y1 square, treat it as x raised to n. So it will be 2y1, okay, and then the derivative of y1 will again be what? Y2, okay. So see, y1 derivative will be y2, y1 square derivative will be 2y1 y2, okay. So here you have to apply x raised to n formula. X raised to n will be what? N x raised to n minus 1, but this is other than x, so the derivative of y1 will be y2, okay. So y1 derivative is y2, y1 square derivative is 2y1 y2, okay. So using this we can differentiate now. So y1 derivative, it will be y2 plus y1 as it is, x derivative is 1, is equal to minus 3. See, sine of log x now. Sine of log x. Sine x derivative is cos, but instead of x, we have log x. Okay. So derivative of log x again, it will be 1 by x. plus say cos of log x. Now cos of log x derivative 4 is constant, keep it as it is. Cos log x derivative will be minus sine of log x, minus sine of log x. Okay, so on simplifying it further, see x y2 plus y1. See again 1 by x is common. Okay, here 1 by x we get, sorry, 1 by x. So 1 by x is common. So when we take 1 by x common, okay, the remainder will be, okay, the remainder will be, see, I will take minus 1 by x. Minus 1 by x if I take common. This will be 3 cos log x. Okay, 3 cos log x plus 4 sine log x. Okay, 4 sine log x. Okay, so this is the value we are getting. And then I am shifting this x to the LHS. So x into what we get, xy2 plus y1. Okay, which will be equal to minus 1, you keep as it is, minus 1. And see, the bracket is nothing but our question. Whatever the question they have given, the function they have given in the equation 1, the same we are getting it here. Okay, so from 1 we can substitute this as y, and on simplifying it further, we get, okay, see, on simplifying it further, we get it in the form of, okay, so multiply ಮಾಡಬೇಕು ಇಲ್ಲಿ x into x, final step x y2, okay, x into y1, okay, and then minus y, if we shift it to the RHS it will be plus y is equal to 0, and this is the required equation. Okay, so they had asked in the question, they have asked us to prove x2 y2 x square y2 plus x y1 plus y is equal to 0. Okay, so here we have differentiated it twice by making use of a product rule. Okay, and we have proved it. Okay, hope the example is clear. Take a screenshot of this. We will proceed to the next question then. Okay, so we will proceed with the next question. Take a screenshot of this. If there is any doubt, you can just put a message in the chat box. We will discuss it at the end of this class. Okay. And see, ಮತ್ತು ಸ್ಟೂಡೆಂಟ್ಸ್ ಇದು 5 ಮಾರ್ಕ್ ಕ್ವಶನ್, ಈ ಕ್ವಶನ್ ಫೇಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ನಿಮಗೆ formulas, okay, formulas are very important. So if you know the formulas, then only you can attempt this question. Without formulas you can't attempt this question. So if you are ನಿಮ್ಗೆ ಎಲ್ಲ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಫಾರ್ಮುಲಾಸ್ ಬರ್ತಾ ಇದ್ರೆ ಅಷ್ಟ ಇದು ಕ್ವಶನ್ ಅಟೆಂಪ್ಟ್ ಮಾಡಬಹುದು. ಓಕೆ, so and once you get the formulas, try to practice it every day. 5 to 6 days if you practice, you can easily remember all the formulas. Okay, and once the formulas are ready, once your formulas are ready, you can easily solve this example. Okay, so we'll proceed with the next question. Question number 3, today's class. Okay, so here see, again the same type, the same pattern. So here the function is given in the form of y is equal to a e raised to mx plus b e raised to nx. Now show that y2 minus m plus n y1 plus m n y is equal to 0. Okay, so this is the question given over here. Okay, so again we will be discussing the proof for this question, solution for this question. So in the to show that part, or to prove that, what do we need to prove? See, we require the second order derivative y2. Okay, we require y2. Next we require y1. So we need to differentiate it 2 times. Okay, first we will differentiate it 2 times and then try to show LHS is equal to RHS. Okay, so see, the first step what we will be doing here is, first step, solution. We will consider the given function y is equal to a e raised to mx plus b e raised to nx. Okay, so this is our equation 1. So we will differentiate 1 with respect to what, x. So when we differentiate 1 with respect to x, y derivative, see, y derivative it will be y1 A you keep as it is e raised to mx. So e raised to x derivative is e raised to x, but it is other than x. So whatever the constant is there with x, it gets multiplied. So it will be a e raised to mx into m. Similarly, b is constant, keep it as it is. The derivative of e raised to nx will be e raised to nx into n. Okay. So this is our equation number 2, the first derivative. Similarly, we need to differentiate it once again, differentiating with respect to x again. So when we differentiate it with respect to x again, we get y2 is equal to, okay, y2 is equal to, so see y1 derivative is y2, a as it is e raised to mx, it will be e raised to mx into m, and already one m is present with us, so m into m, it will be equal to m square. Similarly, b e raised to nx, nx derivative will be e raised to nx into n, so n into n, it will be equal to n square. Okay, and this I will consider it as equation number 3. Okay, equation number 3. Okay, now what I will do is I'll consider the LHS part of the question. See, LHS part is y2 minus m plus n into y1, okay, plus m and y. Okay, so see, y2 value is already we have obtained in equation 3. I'll substitute it a m square e raised to mx plus b n square e raised to nx. Okay, e raised to nx. Okay, and then e minus, see, in the equation m plus n, we will keep it as it is. Y1 we have obtained in the equation 2, substitute the value. Okay, it will be a m e raised to mx plus bn e raised to nx. Okay, and then plus m and y. Okay, plus m and y. So mn, keep it as it is. Mn, we will keep it as it is. We need to multiply it by y. So y value is what? A e raised to mx plus b e raised to nx. Okay, so we need to substitute this and then simplify further. So just we will multiply it. See, the first two terms will remain as it is. A m square e raised to mx as it is, plus b n square e raised to nx as it is. So multiply. First I will multiply it with m. I will multiply both the terms with m. Okay, I will multiply both the terms with m. So m into a m e raised to mx, it will be minus a m into m, it will be m square. Okay, and e raised to mx. Similarly, minus into plus, it will be minus b m into n will be mn. Okay, e raised to nx. Similarly, multiply it with n now, so it will be minus a mn. Okay, a mn e raised to mx, and then minus bn square e raised to nx, and then the last two terms here. So mn into a raised to mx, it will be a mn e raised to mx, and then again multiply b with mn, so it will be b mn e raised to nx. Okay, now see, we can see altogether there are 8 terms. Okay, 8 terms are there. Okay, see, e raised to m square e raised to mx. Okay, this will cancel up with a raised to m square e raised to mx. Similarly, b n square term will cancel up with here b n square e raised to nx. Next, minus amn plus amn will cancel. Minus bmn and plus bmn will cancel. So overall, the answer will be equal to 0, which is the required RHS. Okay. So in this example, first we have found out the first order derivative. Okay, we have found out the first order derivative. Next, we have obtained the second order derivative, and then we have substituted in the required equation. Okay, so here we need to show LHS is equal to RHS. So in the LHS, we required y2, we have calculated y2, we required y1, we have calculated y1, and then y is already given in the question. So after substituting and simplifying it, we get it LHS is equal to RHS. Okay, hope the example is clear. Hope the example is clear. Okay, take a screenshot. We will proceed with the next question. We will proceed with the next question and try to solve the example along with me. If you already have the solution, try to understand the steps. Okay, ನಿಮ್ ಕಡೆ ಸೊಲ್ಯೂಷನ್ ಇಲ್ಲ ಅಂದ್ರೆ ನನ್ನ ಜೊತೆ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಕ್ ನೋಡ್ರಿ, ಅಥವಾ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಏನ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ ಈಗ ಕಾಪಿ ಮಾಡ್ಕೋಬಹುದು ನಿಮ್ ಬುಕ್ ನಲ್ಲೇ, ಆಮೇಲೆ ಕ್ಲಾಸ್ ಆದ ಕೂಡಲೇ ಒಂದ್ ಅಥವಾ ಎರಡ್ ಸಲ ಇದು ಲೆಕ್ಕ ನೋಡಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. So it will help you to score 5 marks in this question. Okay. Next, we will discuss the question number 4. Okay, this question number 4, I am giving it for homework. Okay, because it is similar as question number 3, what we have discussed. So it is similar. And there in place of, see here in the previous question, a e raised to mx. So instead of a 500 is given, and instead of b 600 is given. Only that is the change. Okay, instead of m 7 is given, and instead of n minus 7 is given. So just find out the first order derivative, second order derivative, and show that y square is equal to what, 49y. Okay, we need to show the second order derivative is equal to 49y. Okay, so you will try this for homework. If there is any doubt in the next class, you can ask with this question. Okay, next we will proceed with the next question, important question. Okay, next one. So this is based on exponential function. Okay, so here in this particular question we need to show, okay, we need to show that see, the question is e raised to y into x plus 1 is equal to 1. Show that y2 is equal to y1 square. Okay, we need to show y2 is equal to y1 square. We need to prove the second order derivative is square of the first order derivative. Okay, is square of the first order derivative. Okay, so we will simplify it. So again, as per the question, we require the first order derivative and a second order derivative. So e raised to y x plus 1 is equal to what, 1. Okay, so first we will differentiate this with respect to x. So differentiating with respect to x. Okay, so see the LHS, it is product of two functions, e raised to y and x plus 1. So again we are making use of which rule? We are making use of the product rule. So see, first function as it is, the derivative of second function x plus 1 derivative, x derivative is 1, 1 derivative is 0. Okay, plus x plus 1 as it is, and e raised to y derivative, e raised to y derivative is e raised to y. And since it is other than x, the derivative of y will be dy by dx, and one derivative will be equal to 0. Okay, so on simplifying it further, we get it in the form of, okay, so we get it in the form of, pay attention now here. So see, e raised to y into 1, it will be e raised to y. And see, from the equation 1, okay, from the equation 1, the value of x raised to 1 into e raised to y is equal to 1. So I will replacing this with 1. Okay, I will replace this product with 1 into dy by dx is equal to 0. Or on simplifying further, we get dy by dx is equal to what? Is equal to minus e raised to y. This I will consider it as equation 2. Okay, and then I will differentiate it once again. So differentiating with respect to x again. So when we differentiate it with respect to x again, see the derivative of this dy by dx derivative will be d square y by dx square, which will be equal to minus sign I'll keep as it is, e raised to y derivative. Okay, e raised to y derivative is e raised to y. and y derivative will be dy by dx. Okay, so the derivative of minus e raised to y will be minus e raised to y into dy by dx. Okay, from equation 1 we already know what is the value of dy by dx. Dy by dx is minus e raised to y. Okay, so see this dy by dx square, I'll write it as y2, second order derivative. So y2 I will keep as it is, and see this will be square of, don't multiply the negative sign, keep it as it is. You write it as whole square. Okay, so on simplifying, y2 will be equal to y1 square. Okay, why y1 square? Because minus e raised to y from the equation 2 is nothing but y1. Okay, this is nothing but y1. So here we are substituting minus e raised to y as y1. So we have proved LHS is equal to, so we have shown y2 is equal to y1 square. Okay, hope the example is clear. Very important example on successive derivative. Okay, so here two steps are very important. The first step is the substitution for x plus y. Okay, x plus y into e raised to y, it is equal to 1. And then second substitution is for dy by dx. Okay, so second substitution we are making it for dy by dx. So dy by dx we are substituting it as minus e raised to y. Okay, so on simplifying we get y2 is equal to y1 square. Next we will be continuing with the next question. So these questions you all tried, ಈ questions first understand ಮಾಡ್ಕೊಳಕ್ ನೋಡ್ರಿ, ಆಮೇಲೆ 2 ಅಥವಾ 3 ಸಲ ಸ್ವಂತ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕಾಗ್ತದೆ. ಸೊ ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಡೂ ದಿಸ್. ಈ ಕ್ವಶನ್ ನಿಮ್ಗೆ ಅಟೆಂಪ್ಟ್ ಮಾಡೋದಿತ್ತಂದ್ರೆ ಫಾರ್ಮುಲಾಸ್ ಮತ್ತು 3 ಅಥವಾ 4 ಸಲ ಪ್ರಾಕ್ಟೀಸ್. ದಿಸ್ ಈಸ್ ರಿಕ್ವೈರ್ಡ್. ಓಕೆ, try to practice it 2-3 times. Now try to understand, and then later after the class you will practice it 2-3 times. Okay, so one question occurs every year for 5 marks on successive differentiation. Next we will proceed with the next question now. Okay, so this question is based on inverse trigonometric function. Okay, so see the question over here is, okay, so here we are using the derivative of inverse trigonometric function tan inverse x. So the given question is, if y is equal to tan inverse x whole square, show that x square plus 1 whole square y2 plus 2x x square plus 1 y1 is equal to 2. Okay, so we need to show x square plus 1 whole square y2 plus 2x into x square plus 1, okay, y1 is equal to 2. Okay, is equal to 2. Okay, so see here first two steps are very important. First you need to understand the given function. Okay, the form of the given function. So solution, so we are considering y is equal to tan inverse x whole square. Okay, tan inverse x whole square. So the derivative of this function, see y is equal to tan inverse x. Okay, y is equal to tan inverse x. I am considering this as 1. So the derivative of this, see it is in the form of f of x raised to n. Okay, so it is in the form of f of x raised to n, and the derivative of f of x raised to n is n f of x raised to what? N minus 1. So instead of x, a function is present over here. Okay, so the derivative of this f of x raised to n will be n f of x raised to n minus 1 into d by dx of f of x. Okay, so see using this formula we can easily differentiate this. Okay, we can easily differentiate this function. So differentiating with respect to x. Okay, differentiating with respect to x. So y derivative will be what? Y derivative will be y1, and the derivative of this LHS, it will be 2 tan inverse x, and derivative of tan inverse. Okay, so into derivative of tan inverse x. Okay, so on simplifying we get 2 tan inverse x, and derivative of tan inverse x is 1 upon 1 plus x square. Okay, so we will be shifting this 1 upon 1 plus x square to the RHS, so LHS, so it will be 1 plus x square into y1. Okay, 1 plus x square into y1 is equal to 2 tan inverse x. This I'll consider it as equation 2. Okay, equation 2. So next what we will do is we will be differentiating this once again with respect to x. So differentiating with respect to x. So here we are considering the product of two functions. So here again we are making use of the product rule, PR, okay, product rule. So first function as it is, 1 plus x square as it is, y1 derivative is y2, and y1 as it is, the derivative of 1 plus x square. Now 1 derivative is 0, x square derivative is 2x, and this will be equal to 2 times tan inverse x derivative will be 1 upon 1 plus x square. Okay. So now what we will do is the denominator 1 plus x square, we will shift it to the LHS. So each term will get multiplied by 1 plus x square. So 1 plus x square into, see the LHS is 1 plus x square y2 plus 2x into y1 is equal to 2. Okay. So on simplifying, see 1 plus x square into 1 plus x square. 1 plus x square whole square y2 plus 2x into 1 plus x square, it will be 2x into 1 plus x square y1, and this is equal to 2. Okay, and this is the required proof. So we need to prove x square plus 1 whole square y2 plus 2x x square 1 y1 is equal to 2. Okay, so here the formula, the first step is very important. We are using the formula. Okay, chain rule, we are applying the chain rule and simplifying it. Okay, or you can make use of the formula f of x raised to n. F of x raised to n formula, it will be n f of x raised to n minus 1 into d by dx of f of x. So here n value is 2, so it will be 2 tan inverse x into d by dx of tan inverse x. So the answer will be 2 tan inverse x into 1 upon 1 plus x square. Okay, and then simplifying it, just we need to shift 1 plus x square to the RHS, apply the product rule, and then mm, simplify it, okay, to get the required equation. Hope the example is clear. Okay, now based on tan inverse x, there is a similar example, but instead of tan inverse x, we are making use of sine inverse x. Okay, sine inverse x. So we will discuss the next question. This sine inverse x has also occurred two times in the annual exams, board exams. In the previous 5 years, 5 to 6 years, the question has been occurred two times based on tan inverse x and sine inverse x. So both the questions are very important. Okay. Okay. So the next question, y is equal to, okay, y is equal to sine inverse x. Then show that 1 minus x square d square y by dx square minus x dy by dx is equal to 0. Okay, is equal to 0. So we'll be discussing the next question. So here, see this question again. I am repeating again. I repeat ಮಾಡಕತ್ತೀನಿ. ಈ ಕ್ವಶನ್ ಅಟೆಂಪ್ಟ್ ಮಾಡೋದಿದ್ರೆ ನಿಮಗೆ ಫಸ್ಟ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಫಾರ್ಮುಲಾಸ್ ಬರಬೇಕು. ಓಕೆ, ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಫಾರ್ಮುಲಾಸ್ ಪರ್ಫೆಕ್ಟ್ ಅದಾವೆ ಅಂದ್ರೆ ಇದು ಕ್ವಶನ್ ನೀವು ಅಟೆಂಪ್ಟ್ ಮಾಡಬಹುದು ಎಕ್ಸಾಮ್ ನಲ್ಲಿ. ಸೊ ವಿದೌಟ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಫಾರ್ಮುಲಾಸ್ ದಿಸ್ ಕ್ವಶನ್ is not easy to attempt. Okay, so based on this question, whatever the varieties are there, I am discussing. Okay, so first we discussed for exponential function, then log function. Now we are discussing the same example on inverse trigonometric functions. Okay, so we will continue with sine inverse x. So again, see y is equal to sine inverse x. Show that 1 minus x square d square y by dx square minus x dy by dx is equal to 0. Okay, and see if you require the list of the formulas, let me know. I will upload it in the group. Okay, if you require the formulas of differentiation, if you don't have, or you can make use of your textbook. In the textbook, all the formulas are given. So make a list of the formulas. List ಮಾಡ್ರಿ ಪ್ರತಿದಿನ 2 ಅಥವಾ 3 ಸಲ ಬರೆದು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ರಿ ಫಸ್ಟ್. ಒಂದ್ಸಲ ನಿಮ್ದು ಫಾರ್ಮುಲಾಸ್ ಪರ್ಫೆಕ್ಟ್ ಆದವು ಅಂದ್ರೆ ಇದು ಎಕ್ಸಾಂಪಲ್ಸ್ ಈಸಿಲಿ ಮಾಡಬಹುದು ನೀವು. ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ಸೊ practice the formulas and practice the examples with understanding. So solution for this, so the given function is y is equal to sine inverse x. Okay, sine inverse x, so I'll consider it as equation 1. So we will differentiate this. So when we differentiate y is equal to sine inverse x, the derivative of y is dy by dx. Okay, so when we differentiate this, sine inverse x derivative is 1 upon root 1 minus x square. Okay, 1 minus root of 1 minus x square. Okay, 1 minus x square we get in the root. Okay, so this is the first step. Second step is I will multiply 1 minus x square. Okay, and then dy by dx I'll keep it as it is equal to 1. Okay, now see in the proof over here square root sign is not there. Okay, so to delete that square root sign we are applying a step that is squaring on both the sides. Okay, so we are applying the steps squaring on both sides. So when we square it on both the sides, root of 1 minus x square whole square, it will be equal to 1 minus x square. Okay, and then the second term will also be squared, that is dy by dx, it will be whole square is equal to 1 square is 1. Okay, and now we will be applying the product rule. Okay, we will be applying the product rule. So the first function as it is 1 minus x square as it is. Okay, the derivative of dy by dx square, it will be 2 dy by dx. Okay, 2 dy by dx into the derivative of the first order derivative will be okay, d square y by dx square. Okay, so dy by dx derivative will be d square y by dx square plus, okay, plus see the second function as it is, that is dy by dx square as it is, and the derivative of 1 minus x square is minus 2x. Okay, minus 2x, and it will be equal to 0. Okay, now to get the required proof, okay, to get the required equation, we are taking out 2. Okay, 2 dy by dx common. Okay, so take 2 dy by dx common from the above equation. So when we take 2 dy by dx common, in the first term, say 2 dy by dx is common. So the first bracket, it will be, the first term will be 1 minus x square d square y by what dx square, and then in the second bracket we have, see 2 dy by dx I am taking common, it will be just minus x dy by dx is equal to 0, and on shifting this term to the RHS we get the required proof, that is we get the final step. Okay, so the final step I am doing it here. Okay, the final step what we do, we shift that, and then we will get 1 minus x square dy by d square y by dx square minus x dy by dx is equal to 0. Okay, so this is the required proof. Hope the example is clear. So sine inverse tan inverse, and one more example based on this we will be discussing. So today's last example we will discuss. Okay, and this question, so this question, y is equal to 3e raised to 2x, 2e raised to 3x, then prove that d square y by dx square minus 5 dy by dx plus 6y is equal to 0. Okay, this you all solve it for homework. It's a easy question. Okay, next we will be solving a very important question. Okay, so see it is mixture of exponential as well as trigonometric function. So see, pay attention, a very important question. This question has also occurred one time in the board exam, Karnataka board exam. So mark it important also. Okay, the question is important. The steps are similar to tan inverse and sine inverse what we discussed previously. Okay, so see the first step over here, solution. we get it in the form of, so y, okay, y is equal to, okay, y is equal to ea raised to cos inverse x, okay, ea raised to cos inverse x. So here the first step what we are doing is we are applying log, okay, we are applying a log on both sides, apply log on both the sides. So applying log on both the sides. So when we apply log on both the sides, we get a log y. Okay, log y is equal to a log of, okay, log of e a raised to cos inverse x. Okay, so we get it in this form, and here we are using a formula, a log of e raised to f of x, it is equal to what, f of x. Okay, so if log and e both are occurring in the function, then directly it will be equal to what, f of x. So this step, using this formula, we can write log of e raised to a cos inverse x, it will be directly equal to a cos inverse x. Okay, and this is a very important step in this example. So log y will be a log of e raised to a cos inverse x will get reduced to a cos inverse x. So now we will be differentiating this. Okay, so differentiating the above function, log y derivative is 1 by y dy by dx. Okay, 1 by y dy by dx is equal to a, as it is, cos inverse x derivative is minus 1 upon root 1 minus x square. Okay, and then see, further on simplifying, we will cross multiply it. So it will be 1 minus x square into dy by dx is equal to minus ay. Okay, it will be equal to minus ay. See, again in the equation over here, square root sign is not occurring. Okay, so we need to square it on both the sides. Same steps. So square on both the sides. So when we square on both the sides, we get it in the form of 1 minus x square dy by dx. Okay, dy by dx whole square, which is equal to minus a y square. See, minus a square, it will be a square and y square. Okay, so we will get a square y square. And now again we will be differentiating this equation. So differentiating with respect to x. Okay, so when we differentiate this with respect to x, further, say, pay attention. So further again we are differentiating with respect to x. So the product rule we need to apply. So 1 minus x square, as it is, the derivative of dy by dx whole square, it will be 2 dy by dx into d square y by what, dx square. Okay, plus dy by dx whole square. Okay, dy by dx whole square into 1 minus x square derivative is again minus 2x, and a square is a constant as it is, y square derivative will be 2y. Okay, it will be 2y into dy by dx. Okay, into dy by dx. So again what we are doing is we are taking 2 dy by dx common. Okay, so when we take 2 dy by dx common, we get it in the form of, see, 2 dy by dx is common. So the first term, the remaining term will be 1 minus x square, 1 minus x square d square y by what, dx square. Okay, plus minus, see, x dy by dx will remain. Okay, and on the RHS we have already a square 2y 2y dy by dx. Okay, so here see, dy by dx and 2 will cancel off with this. Okay, and the final step will be 1 minus x square d square y by dx square minus x dy by dx. Okay, x dy by dx minus a square y is equal to 0, and this is the required proof. Okay, so this is the last example for today's session. So we have covered a 5-mark question, 5-mark question in differentiation. Okay, which is based on the concept of successive differentiation. Okay, so try to practice these examples. Okay, and finally there is one more question. We will you can solve it for homework. You can take down one more question. Okay, this is the last question here of today's class. So here what we need to do is, okay, what we need to do is the given, see, same again, it is in the form of trigonometric function, okay, mixture of trigonometric function. So if y is equal to a sin x plus b cos x, we need to prove d square y by dx square plus y is equal to 0. Okay, so it is similar to the first example what we discussed in the today's class. Okay, so refer to that example and try to cover this question. So we will stop here. Okay, if you have any doubts, you can put a message. If there is any doubt, you can put a message. Okay, so hope you have understood the example. I hope you have understood the examples, today's examples. We will stop here, and in the next class we will be discussing a 3-mark question on differentiation. Okay, a 3-mark question which have occurred in the previous year's papers. So we will be discussing a 3-mark question on differentiation. Okay, bye. Take care. Practice properly for the upcoming exams. Okay, we will meet you. I'll meet you in the next class. Okay, bye.